Hello. In this video we're going to be looking at the vector cross product, which is one of the two ways in which you can multiply vectors, and it is a little complicated. It's something that always trips people up. In physics you'll most likely encounter this the first time in dealing with magnetism, but you may see it in terms of rotation as well. So first, let's go over the components of a vector and our directions, because when we do the cross product, it's inherently three-dimensional, so we have to account for all three dimensions. So I write the vectors with the symbol with the arrow on top. They'll have x, y, and z components, where plus x is to the right, minus x is to the left, plus y is up, minus y is down, and then for the third direction, z, plus z will be out of the page, the board, the screen, and minus z will be into the page, board, or screen. Before we get into the math of the cross product, here are some just important general properties. The cross product is where you multiply two vectors and your result is another vector, and it's a vector that's perpendicular to the two original ones. And when you're doing the multiplication, it's basically picking out the perpendicular elements of the two original vectors. And most importantly, the cross product is going to equal 0 when the two vectors a and b are parallel. Now you may or may not see the full definition of the cross product, but it's a little ugly. If you've done linear algebra, or matrix math, it's a determinant of the following matrix, and you can see that it splits up into x, y, and z components, and a useful memory trick to know the order of things is the positive order is x, y, z, x, y, z, the negative order is anything that's out of bounds. But you can see in the most general case the cross product is pretty ugly. That being said, for simple vectors it's not too bad, but you still have to be careful with the direction bit in order to get the third vector being perpendicular to the two original ones and then pointing the right way. So again, the cross product is going to select the perpendicular elements of the two original vectors, and the way you figure out the proper direction for the result is through doing what's called the right-hand rule. And you'll see a number of different descriptions for the right-hand rule, but this is the one I think is the clearest. First, you have to point your hand like a finger gun, like in the illustration there, and your pointer finger will go in the direction of the first vector A, your middle finger will go in the direction of the second vector B, and your thumb will point in the direction of the result. And regardless of where those two original vectors are pointing, you're always going to keep your hand in that shape. So you'll just rotate your hand however which way you need for the particular problem. To give you an idea of how this works, we're going to do a number of examples here. So first, let's do a case where we have two vectors that are each pointing just in a single direction. Because if you have them two vectors going in, say, two or three different directions, you have to resort to the full form. But if it's only in one direction like this, you can get by with just the right-hand rule. So our first vector is minus 2 in the x direction. Our second vector is plus 5 in the z direction. And since the first one's only in x and the second one's only in z, they're perfectly perpendicular to each other, so we can get the magnitude just by multiplying those two components, 2 and 5. We'll account for the signs when we do our right-hand rule. And so now we'll do the right-hand rule. Our pointer finger goes in the direction of the first vector, which is minus an x, so our pointer finger is going to the left. Our second vector is positive in z, so that means out of the board, out of the page, out of the screen. And keeping with the finger gun shape, your thumb will be pointing straight up, which is positive in y. So we'll put those together. We have our direction is positive in y, and the magnitude we get by multiplying the components 2 and 5. But again, your first vector is your pointer finger, second vector is your middle finger, thumb is a result. Let's look at our next one. So in the next case, we have our first vector is negative in x, and the second vector is positive in x and negative in z. Again, the cross product is just going to select the perpendicular elements of the two vectors. So since the first vector is only pointing in the x direction, we can ignore any x components in the second vector. So we can basically get rid of that 2 in front. So our cross product is equivalent to minus 3, 0, 0 crossed into 0, 0, minus 5, because we only care about the perpendicular parts. So our magnitude will be 3 times 5, or 15. So now we'll do the right hand rule. So our pointer finger goes in the direction of the first vector, and the first vector is negative in x going to the left. The second vector, the part we care about, is negative in z, so into the board, into the screen, what have you, and your thumb will be pointing straight down negative in y. So put those together, we have a cross product is minus 15 in the y direction. Again, first vector is negative in x, so the pointer finger goes to the left. Your second vector, the perpendicular part, is negative in z, so the middle finger is pointing into the screen or into the page, and your result, your thumb, is going to go straight down negative in y. So here's another case where we have a vector in 2 directions and the second vector in 1. So if we look at our second vector, the second vector is only in the y direction. So we can ignore any y components in the first vector. So we can rewrite our cross product as 0, 0, 4 crossed into 0, minus 1, 0. Because again, we only care about the perpendicular pieces. So the magnitude of the cross product is 4 times 1, which is 4. Again, we'll account for the signs when we do our right hand rule. So our first vector, the part that we care about, is positive in z, which is out of the board, out of the screen. And the second vector is negative in y, so our middle finger is going down. That will leave us with our thumb pointing to the right, positive in x. So our cross product is then plus 4 in x. Again, pointer finger is your first vector, middle finger is your second vector, thumb is your result, and you only care about the perpendicular pieces of each vector. So in this case, our first vector is positive in y, our second vector is positive in y and negative in z. Since our first vector is only pointing in the y direction, we can ignore the parallel y component in the second vector, and we only care about the perpendicular z part. So our cross product is equivalent to saying 0, 7, 0 crossed into 0, 0, minus 3. So our magnitude is then 7 times 3, which is 21. So our first vector is positive in y, so our pointer finger is going up. The part of the second vector we care about is negative in z, so our middle finger is going into the screen or into the page. And your thumb will be pointing left, which is minus in x. So putting that together, our cross product is minus 21 in x. Now we have first vector is negative in x, positive in z, and our second vector is negative in x. Again, if one of our vectors is only in the x direction, we can ignore the parallel x part in the first vector. So this is equivalent to saying 0, 0, 8 crossed into minus 5, 0, 0, because the cross product only cares about the perpendicular pieces. Our magnitude will be 8 times 5, which is 40, and again, we account for the sign when we do our right hand rule. So our first vector is positive in z, coming out of the board or out of the screen. Our middle finger is our second vector, negative in x, going to the left, so your thumb will be pointing straight down, negative in y. So our cross product is then minus 40 in y. Lastly, we have 0, 7, 0 crossed into -3, -3, 0. So our first vector is only in the y direction. We can ignore the y component in the second vector since we only care about what's perpendicular. So if we multiply those perpendicular elements, we have 7 times 3, which is 21. Now let's do our right-hand rule. Our first vector is positive in y, so our pointer finger is going straight up. Our second vector, the perpendicular part, is negative in x, so our middle finger is going to the left, and then therefore your thumb will be pointing straight out of the board, out of the page, positive in z. So putting that together, we have our cross product is plus 21 in the z direction. If you get into a cross product where you have a vector that's in one direction and the second vector is in 3 directions, or you have 2 directions crossed into 2 directions, you have to go back to the full definition of the cross product. But if you have simple cases like this where you can just isolate the 2 vectors each into a single direction, you can do the shorthand method, where again the magnitude of this cross product you get by multiplying those perpendicular pieces, and then you use the right hand rule to get the direction, where your pointer finger goes in the direction of the first vector, your middle finger goes in the direction of the second vector, and your thumb goes in the direction of the result. And you always keep your hand that shape, you just rotate your hand however way you need for that particular problem.